is a near-perfect sphere to better than 99% precision. But what if it was flat? If our planet was truly flat, it would not behave much like the planet we know today. In fact, humanity wouldn't exist at all. Based on how the physics work, you would need to spin the Earth extremely fast to shape it into a disk. As a result, this centrifugal force would destroy the planet by tearing it into tiny particles. That's why there are no planet-sized disks floating around the galaxy. Ancient astronomers believed comets foretold the death of princes and the outcomes of wars. Modern astronomers know a comet is just a small solar system body that displays a coma, an atmosphere of a sort, and sometimes a tail passing close to the sun. These dirty space snowballs of mostly ice and dust, and not rock, formed during the birth of the solar system 4.6 billion years ago. As a comet's orbit takes it toward the sun, the ice and dust heat up and begin to sublimate from solid to gas. That sublimed ice and dust become the comet's tail, so it's easy to spot comets even when they are far from Earth. A second tail is formed when high-energy solar particles ionize the gas, creating a separate ion. When someone asks what would happen if a human fell on a black hole, most would probably expect to die instantly. But the reality is way stranger than that. If you were to come too close to a black hole, you would get spaghettified. So Martin Rees coined the term spaghettification, which is a perfectly good way to put it. You'd eventually become a stream of subatomic particles that swirl into the black hole. If you jumped into a black hole feet first, the gravitational force on your toes would be much stronger than that pulling on your head. And as you accelerate toward the black hole, gravity would stretch you so much you'd be fall into a stellar mass black hole. You probably wouldn't worry much about the mysteries you might have been able to unlock on the other side. You'd be as dead as a spaghetti-shaped doornail, hundreds of miles before you hit the singularity. It would be a rocky ride as your matter perturbs the environment and the space-time undulates. The reason we know this is because astronomers actually observed something similar to this. In 2014, several space telescopes observed a star passing too close to a black hole. While the black hole stretched and shredded the star, some of the material fell beyond the event horizon, while the rest was blown back.
Scientists around the world thought the expansion of the universe was slowing down, but when Hubble started to observe it, found out the universe was in fact accelerating. The legendary spacecraft was able to see far-off supernovae, concluding that the universe wasn't slowing down at all. The space telescope discovered that when dark energy became dominant, the expansion began. Dark matter makes up about 23% of the universe. By analyzing the distortions caused by dark matter's gravity on light from distant galaxies, Hubble helped construct the largest scale 3D map scientists have of where dark matter is distributed in the universe. Hubble's findings suggest that dark matter clumps together as
One is a tiny star about the size of Jupiter. Most of the planets orbiting it are rocky. What makes this system interesting, however, is that some planets could potentially hold more liquid water than Earth. Some of the planets might have up to 5% of their mass in liquid water form. That's about 250 times as much water as found in Earth.
To know that I'm never leaving, 'cause I miss the snow till death will be freezing. Yeah, you are my home.
The closest planet, TRAPPIST-1b, orbits around its star once every 1.5 days. 7. Far, far out's current distance from the Sun is 132 astronomical units. The object has a very elongated orbit. It takes it out to 175 AU at its most distant, and to around 27 AU inside Neptune's orbit.
The dwarf star Gliese 710 is headed straight for our solar system. The star orbits in the galactic plane on a pretty normal orbit, but it just happens to be on an orbit that intersects with the Sun's orbit. Astronomers calculate that the star will cross into our solar system's Oort cloud of comets, some 1.3 million years.
Will launch on an Ariane 5 rocket into space to the L2 Lagrange point, some 1.5 million kilometers more distant than Earth. Voyager 1 is the most distant human-made object and is now over 14 billion miles away from Earth, or 151 astronomical units away from the Sun. For comparison, Earth is just 1 astronomical unit away from the Sun, and Neptune, the farthest planet, is 30 astronomical units away from the Sun. Signals from Voyager 1 take over 20 hours